Okay, ladies and gentlemen, let's talk about systems of linear equations. Now remember, a linear equation is the equation of a straight line. So if I have y equals 3x plus 2, that would be the equation of a straight line, okay? And if I were to take that equation, I put it on the graph, I go 1, 2, and then I put a point, I go 1, 2, 3, 1. I can draw that line right up on here. Now, if I also have another line, let's say I have y equals negative 1/2 plus 3x plus 3, 1, 2, 3, but down 1 over 1, 2, down 1 over 1, 2. And now I have another line right over here. So whereas the orange by itself is a linear equation, the orange, when I put another graph with it, the blue, now they become a system of linear equations. Now, a system is something that's made up of multiple components. For example, a computer system has a monitor, a computer, a mouse, a printer, may have a keyboard, may have any other number of things, but it's a system. It's a computer system. A plumbing system is going to have some sort of pump. You have water coming in. You got to send it through pipes. Then you have faucets where you have outlets. Then you have drains that catch what comes out of the outlets. Then you have pipes that carry away the waste. And the whole process starts again. It's a system. Now, in this case, by having two linear equations, we have now a system of linear equations. But there are a couple different types of systems because there are a couple of different ways lines can be related. I can have lines that cross. That would be crossing once. I could have lines that are parallel. And I could have lines that are actually on top of each other, where they actually are the same exact line right on top of each other. So in that case, we could have a system that looks like this. One line here, one line here. They're going to cross, and they're going to cross at one point. Now, that one point is called a solution to the system. And that's going to be important because what we're going to do is we're going to be finding solutions to systems of lines. In this case, there only happens to be one solution to that system. This solution, or this system, will be called consistent, and independent. Consistent and independent because they cross, but the two lines are independent of each other. They can be at all sorts of different angles. So consistent but independent. Now, you have one line like this, but what if the other line is right on top of it? So I have two equations, but they end up making lines right on top of each other. This is also consistent, but now they are dependent because if they're actually the same line, if they're together, as one moves, the other one's going to move. So they're consistent and dependent. The thing about it is every point on one line is actually on the other line. So instead of just having one point where there's a solution, we actually have infinite solutions. So we have infinite solutions. Infinite solutions means we have as many. There's no limit to the number of solutions that we have. Now, the other way lines can be related is I could have two lines and they could look like this and be parallel. If two lines are parallel, the system is called inconsistent. And an inconsistent system has no solutions. No solutions because they never, ever, ever, ever touch. What we're going to talk about is different ways to solve systems of linear equations. And the names of those three methods are number one, graphing. Number two, combination/elimination. And finally, substitution. So we have graphing, combination, elimination, and substitution. So we need to know some vocabulary pieces for systems equation: consistent, independent, one solution; consistent, dependent, infinite numbers of solutions; inconsistent means they're parallel. But the way we would find all these is by graphing, combination/elimination, or substitution. All right.